Okay, so looking at this problem today, starting out for do now, this is actually the beginning of our lesson for today. Hopefully it's something that we should have been able to do on our own. Alright, so it says suppose you receive $10 from your grandmother for your birthday. You spent $4 on snacks. Use addition to find out how would you write this number as a number sentence to represent the situation. So looking at this, we're starting with a positive $10. And we spend $4, so we're going to add a negative $4. So using addition, that's what the focus here. So we can see here that this addition is indeed the same thing as adding its opposite, or adding negative. This adds up to give us 6. How would we model this equation on the number line? So we would start at 0. We could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we know that we would need to go back from there the negative 4. 1, 2, 3, 4. And that would give us our end location of 6. So this was negative 4. This was our positive 10. Alright, so hopefully we've got that all sorted out. That's mostly review from yesterday, but also part of our lesson for today. So let's flip on over and write down our aim. So our aim for today is that Kipsters will be able to use arrow diagrams to add integers. So as I walk through the example in part F, you should be able to complete the sentences above, as I will use that language to go ahead and show you how to use the arrow diagrams. So using an arrow diagram, we're always going to start at 0 no matter what. So I'm going to start here at 0. This is the tail of my arrow, starting at 0. And then because it's a negative 2, that means it moves to the left. And so it's just basically, instead of doing the hops that we did yesterday, draw an arrow that ends 2 units to the left. Okay, and that's going to stop us at negative 2. And the arrow is moving to the left since we're counting down. So I'm going to start the next arrow for my plus 3 right where I left off, here at negative 2. And because it's a positive 3, I'm going to be moving to the right 3 units. 1, 2, 3. And that stops me at 1. And so I'm going to go ahead and circle the value that I ended up at. So this is my plus 3. This is my negative 2. Alright, so hopefully you filled in the blanks up here. We always start by placing the tail of the first number on the 0. We drew 2 units to the left, so we stopped at negative 2. And the direction of the arrow is to the left since we were counting down. We started the next arrow right where we had just left off, which was at negative 2. And we're going to draw that arrow, since it's a positive 3 units to the right. And again, we're moving right because it's positive. And that stops us at 1. So that's our ending value. So I'm going to do the same thing here for 3, negative 2. Please go ahead and show me what that would look like as an arrow diagram on your own. Okay, so again, we're starting at 0. We're starting with a positive 3, so we're moving forward 3. Let's say positive 3. And then we have our second value is negative 2. So I'm going to move backwards 2 to negative 2. So looking at this, again, we end at positive 1. So what can we say about the sum of negative 2 and plus 3 and the sum of 3 plus negative 2? Does order matter? So order does not matter. You can see we get the same value. Does not matter when adding. because addition is commutative. All right, so go back and think about what does it mean to be commutative. So this goes back to the commutative property that we learned about last year in 6th grade. The commutative property states that we can add numbers in any order that we want and still get the same result. It also tells us the same thing about multiplication, but today we're only focused on addition. So it's commutative because no matter what order we add them in, we're going to get the same result. And we just have a little bit of proof of that right here in this particular problem. Okay, so sliding on over, how does absolute value determine the length of an arrow for -2? So we know that the absolute value of -2 is equal to 2. And we're moving the units, we're moving this, we're starting with this negative, with this value here, and we're moving it -2. And so we're moving it 2 units long. So when we're talking about absolute value, we are not worried about which direction it is. We're just worried about how far is it moving. So as another example, down here, we would have the absolute value of 3 is equal to 3, because when we draw it on a number line, I'm just going to do it up here on the same number line. Again, what we're focused in on here is that this is 3 units. That's how far it's moving. So when we're talking about absolute value, we're just talking about how far it's moving. I don't really care what direction it's moving in. So how does absolute value help you represent -10 on the number line? Well, if the absolute value is 10, the absolute value is 10, then the arrow should be 10 units long. And that's just really important thinking about how far we're moving things or how differently we may be using things. We should focus back that the absolute value tells us how far to go, and the sign in front, or the lack of sign in front, tells us whether we're moving to the left or to the right. Okay. All right, so go ahead and work independently through questions A through F here, and we'll go ahead and go over them in a minute. So if you need to, pause the video so you can get this all done before you move on. Okay, walking through this, we should see that we start with a positive 5 arrow, so that means we're starting with 5. And then we have a -2 arrow, so we're adding -2. And then a positive 3 arrow is what we're adding on here. We see that we end up at 6. So even without having to think about it, we should know that this is going to be equal to 6. What 3 cards are represented in this model? Well, this would be 5, -2, and +3. The arrow lengths and directions tell us that. And their directions. So even if they weren't labeled, we would know based on their lengths and their directions. In what ways does this model differ from the ones we used in Lesson 1? So in Lesson 1, we used counting loops. And these are just straight arrows. This is straight arrows. Can you make a connection between the sum of 6 and where the top of the arrow ends on the number line? So the top arrow ends at 6. So the sum is 6. That's how this particular diagram works. Would the same sum change if we change the order in which we add the numbers, for example? Could we change it to -2 plus 3 plus 5? Would that change the values? Our answer here should be no. The order of addition does not matter. And in parentheses here, I'm going to put commutative property. Commutative property. All right, would the diagram change? Okay, so our diagram would change. The order of the arrows would change. But the result would still be the same. All right, so let's look on over here now at these next couple of problems. These are ones that I want you to do on your own. I want you to go ahead and use an arrow diagram for these. To go ahead and answer these. That should give you a handful of minutes to go ahead and complete these 2 problems. So go ahead and pause the video until you have these complete, and then come back to check. Okay, so looking at this one, the first one, you can see I started with an arrow diagram of -3, taking me back to -3. Moving the next one is 5 forward, takes me to 2. Moving 4 more forward takes me to +6. And then our last one, 5 backwards, takes me down to +1. So our final position is 1. The sum of these things would be 1. And we could use -1 or some combination that adds up to -1 to get back to -1. All right, so the sum of the cards on the below, again, this one is 3, but we're moving in a positive direction. So I have an arrow that's 3 units long. I have a -6, so we're 6 units long in the backwards direction. That puts me at -3. Then I add 4 more. That moves me to 1, and -5 takes me back to -4. All right, go ahead and flip on over to your independent work. Once you get that done, make sure that you've moved on to York On.